Hello and welcome to this video series. I'm so glad that you've joined me. We've called this series Essential Skills for Physical Science, and this particular series of videos focuses on paper 1, which is the physics paper. Although it's a matric workshop, matric is a 2-year curriculum and it will be just as relevant to grade 11 students as well. You have a booklet in front of you and I encourage you to write your name and your school on the front, as this will be your booklet, and this allows me to introduce myself. My name is Dr. Derek Fish. I'm based at the University of Zululand. For the past 30 years, I've been director of Unizulu Science Centre. And the University of Zululand is committed to its future students by getting involved with matrics and grade 11s and helping them to do better in their matric exams. I've been running matric workshops for the past 25 years, and these have been presented probably to over 200,000 students, many of whom have gone on to graduate and study in the sciences. In 2020, we wanted to continue these, but lockdown got in the way. And we were determined to put across this important idea that facts fade, experiments expire, but skills stick. And that's why we've called this Essential Skills. So lockdown seemed to be preventing that, and we wanted to do it digitally, but I was very concerned by this, that not all kids have the same opportunity. So with the help of South 32 and the South African Institute of Physics, we made this series of videos, which are available online, but have been distributed physically on memory sticks, along with a new 72-page booklet. What's important is the series is grounded on the curriculum. Relevant theory is presented, but only relevant theory, not complete theory. And it should be used after the sections have been taught and in addition to your own notes and your textbook. Experiments will be performed, simulations studied, then exam questions explored in the light of these, and each video finishes with an inspiring interview. So when the relevant theory is presented, it's presented as a useful summary, like this summary of all the motion graphs. Experiments will be performed live on screen, allowing you as students to capture the data, draw the graphs, and come to your own conclusions. Where it's not easy to do experiments, simulations like this one for the photoelectric effect from PHET will be used, and a number of others, especially from PHET. Now, again, don't just take my word for it that this is useful. Here's a comment from the 2019 National Exam Report. The examiner said, teachers must include the use of ICT during teaching of science, especially software such as PHET simulations. And in the teacher pack, there's a complete offline download of PHET. We'll also look at real life applications like the solar powered car, which drove right around South Africa with no petrol or battery charging at all, just using the power of sunlight. Or this amazing solar powered aircraft from NASA, which can stay in the sky as long as there is sunlight. Each video finishes with an inspiring interview with someone from the world of physics, academia, or industry. But before we get into all that exciting stuff, we need to start off with an exam introduction so we can put everything in its context. So let's get into that exam introduction. So please open your booklets to page 3. You'll see in my bottom right-hand corner, you'll always find the page number. Now your page numbers are in your top right-hand corner, but if you just check on the screen in the corner, you'll always be able to see where we are. On page 3, you'll see your table of contents. And remember, this is an essential skills workshop. We're going to look at 4 essential skills: graphs, free body diagrams, equations, and multiple choice and ratio questions. Using those, we will cover all 10 of the exam questions in paper 1. But again, I must remind you, this is not a content-based workshop. It is focusing on those skills. Now, the first of those skills is graphs. And why do I think graphs is important? Because in the National Exam Report, the examiner had this to say: interpretation of graphs and graphing skills is a challenge for many learners. So we'll do some general introduction to graphs and then look at 4 specific examples of graphs that come up regularly in paper 1. Motion graphs, the photoelectric effect, Ohm's law, and internal resistance. And I think we'll do an experiment for each of them. And I think you'll see that these experiments really help you to understand the theory. Just expanding this contents page so it matches yours, the bottom of your page 3. We'll then look at free body diagrams. And again, the examiner's comment, learners struggle to draw and label free body diagrams correctly. Now, you might say these are only for 3 or 4 marks, but remember, drawing the free body diagram correctly is often the key to unlocking the whole question. Then a very large section is equations, and the examiner's comment, learners still cannot work with scientific equations or formulae. These actually cover about 70% of the marks in paper 1. So they are very, very important. So we'll give some general introduction to equations and then look at specific examples of solving equations throughout the paper. Finally, multiple choice was one of the worst answered section in last year's paper. We'll look at multiple choice questions and particularly a specific type, which we will call ratio questions. As the examiner commented, multiple choice is one of the weakest sections and learners need practice. So I mentioned that this series of videos is dealing with paper 1, which is the physics paper. Now, maybe you're still wondering, what on earth is physics? Now, some students came up with this definition. If it moves, it's biology. If it stinks, it's chemistry. If it doesn't work, it's physics. Well, that's just a little bit of fun. If we really want to know what's in the physics curriculum, we will, of course, go to the CAPS curriculum guide. Notice we've turned over to page 4. You can see in my bottom right-hand corner. So you can turn to page 4 in your booklet as well. Now, this is straight from the CAPS curriculum guide, which your teachers have access to. And it's an important document to know what is in your exam and what is not in your exam. Physics is divided up into 4 sections. And we're really looking at a 3-year curriculum, grade 10 to 12, although it's mostly the grade 11 and 12 work. The largest section is mechanics. Please, that doesn't talk about someone who fixes a car, but this deals with motion. Then we've got a small section on wave, sound, and light. And in particular, in grade 12, the Doppler effect comes up in question 6, is the largest part, which is examinable. Then we've got electricity and magnetism. And again, particularly for grade 12, we look at electrostatics, electric circuits, including internal resistance, and electrodynamics. And then finally, matter and materials. This is a crossover section. Also appears in paper 2, the chemistry. There's nothing in grade 10 and 11, but in grade 12, we do look at optical phenomena and the properties of materials, and particularly the photoelectric effect. Now notice if I go back through these, we've underlined some of the sections, and you'll see it says at the top of your page that content which involve graphs is underlined. And you can see graphs come up through everything. So we will be looking at graphs as our first topic. Also, the prescribed and recommended experiments in green, we will try to do as many of these as possible as we go through the different parts of your curriculum, as outlined on page 4. Let's turn to page 5. So at the top of page 5 is a reminder that there are selected examinable sections from grade 10 and 11. So please don't fall asleep and forget your grade 10 and 11 work. Physics from grade 11, Newton's laws, his first, second, and third laws, and universal gravitation, and the applications of it. Electrostatics, Coulomb's law in electric fields, and electric circuits, Ohm's law, power, and energy. We won't talk about the chemistry for now. But again, a comment from the examiner. Grade 10 and 11 work is poorly understood, and this work should be integrated with work done in grade 12. So if you fell asleep in grade 10 and 11, it's time to wake up. Let's have a look at the outline of your exam and the skills and cognitive levels. So there's paper 1 and paper 2. First thing to notice is each paper is 150 marks, and you have 3 hours or 180 minutes. So you need to work at least 1 minute per mark, and that'll still leave you 30 minutes, maybe 10 minutes at the beginning to read through the paper, and 20 minutes at the end just to check and to finish off. Now, once again, we've got various levels of question, and notice this comment from the examiner that recall questions were very poorly answered and that keywords and phrases were left out. Now, recall questions are simply learning work, so it's very important that we do get on top of that. These count 15% of your paper 1. Then we have level 2 questions, which involve understanding, maybe one-step calculations. Level 3 questions, it's now getting like juggling 3 balls. Maybe two-step calculations we have to analyze and apply. The level 4 questions will only comprise 10% of the paper, so don't worry about them unless you're a 90% candidate. Those will be a lot harder, but please make sure that you learn your recall questions and that you can answer those ones well. Now, looking at the breakdown of different sections, although there are 4 sections, they're not equally weighted. And those numbers probably are a little bit easier to understand if we put it in a pie chart. So you can see that mechanics and electricity make up 80% of the paper, and then waves and light and properties of matter, the photoelectric effect, just 20%. There are always 10 questions. The first question is always a multiple choice question, then 4 mechanics questions, 1 question on waves, which is the Doppler effect, 3 electricity questions, and the photoelectric effect question is question 10. At present, this will always be the same, and so you can prepare for this and know what to expect. Now, the questions themselves have got different weightings in terms of how many marks there are per question. And here are the marks per question for 3 recent exam papers. You can see question 1 multiple choice is always 20. Otherwise, it varies, but not very much. And it's probably more useful to look at the average marks per question. And you can get an idea of it here. Questions 6 and 10 are usually about 12 or 13 marks. Questions 7 and 8 are your longest questions for almost 20 marks. So the number of marks per question does vary. The one that's always the same is multiple choice. Now, obviously, performance also varies from year to year, from province to province, and from pupil to pupil. And we'll talk about that in a moment. Just summarizing, 20 marks for multiple choice, 56 marks for mechanics on average, 12 marks for Doppler effect, 49 marks for electricity, and 13 marks for the photoelectric effect. So back to performance. Here is a selection of papers from the 2020 November exam. It's not all the figures, but it's a realistic selection. And you can see that the average performance was really an average performance. Most of the questions, the average mark achieved was just slightly above or slightly below 50%. There were none that were very good, and there were none that were particularly bad. A little bit worrying was multiple choice at just 44%. That really should be higher. And obviously, we would like to see the marks in all these sections improving. And it wasn't very different in different sections. 44% for question 1 multiple choice. Mechanics questions are 4 questions on average 52% per question. Doppler effect, 58%. The electricity, the 3 questions averaged 50%. And photoelectric effect was a little bit low at 43%. But if one looks at the sub-questions, this comes straight from the examiner's report, you can see there's tremendous variation from some that are up in the 80s and 90s to others I've marked in yellow, which are below 33%. And we'll take particular care to look at those highlighted in yellow, which seem to have been problem questions. So on average, 2020 November was an average performance. And in fact, the average total mark was also 50%. There you can see the different sections: mechanics, Doppler effect, electricity, and photoelectric effect. Now, just a word about recall questions. In last year's paper, November 2020, there were 9 recall questions. There was exactly 1 for each of the longer questions. And you can see I've delineated them there. And in every case, they counted for 2 marks. So 9 times 2 marks is 18 marks. Now, 18 marks is actually 12%. And that can be the difference between 29% a fail and 41% a pass, or 69% a good mark and 81% an excellent mark. We are actually not going to deal with these during the videos because they are simply learning work. And you'll be asked to define or state or describe something. These come up very regularly from year to year. And these are just abbreviated answers I've given here from the memo, but teachers can get the exact answers from the memo. It is important to learn them, but make sure that you understand them as well. And if it's for 2 marks, then you can bet that there are 2 important things which need to be said. Here are the average marks for each of these questions last year. Mostly they were fine, but you can see that question 5.1 and 8.1, the marks were very low considering this is learning work. So again, a comment from the examiner, recall questions were very poorly answered. Keywords and phrases were left out. So please make sure you take the trouble to learn your recall questions, your definitions and statements, as we are not going to deal with them again during these videos. So let's move on to the exam itself. Now, although exams are the least exciting part of science, they are very important, and your matric exam represents your future. I've gone to a great deal of trouble to help you prepare for this exam, in particular looking at the November 2018, 2019, and 2020 paper 1, comparing questions side by side so that we can look for trends and help you find strategies. Please remember, it's no good just to get the answers to one question. That exact question will never come up again. You must know how to answer that type of question and develop strategies and skills which will help you no matter what is asked. So here's a side-by-side snapshot of the long questions for the last 3 papers. Question 2 always deals with Newton's laws, especially his second law, force equals mass times acceleration, and it averages about 17 marks. It was quite well answered in the November 2020 paper, with an average of a representative group being 57%. Now, if you look at these pictures from the last 3 years of papers, you can see at least 2 examples of a block on a table and a falling mass piece connected via a pulley. So this has come up again, 2019, it was 2 blocks connected together on an inclined plane. We will be handling all of these questions very carefully when we come to that particular video. Question 3 deals with vertical projectile motion and often involves graphs of motion. You can see the last 2 years, there have been graphs of motion, position time graphs. And last year was a bouncing ball graph, a favorite with the examiners, and all the questions were around the graphs. So the forthcoming videos on graphs are very, very important. With projectile motion, you can see these 2 pictures. The questions are often very similar. And we've developed a very careful strategy to help you to know which equations of motion to use and how to answer these questions. On average, this counts about 15 marks. It was not particularly well answered in last year's exam, I think because pupils didn't have the requisite graph skills. So let's make sure that we have the right graph skills. Question 4 deals with momentum. It's normally a shorter question, averages 12 marks. Last year it was reasonably well answered, average 54% for performance. You can see 2020 was a straightforward collision between 2 balls, momentum before, momentum afterwards. Previous year, a bullet being fired through a wooden block, and the previous year, a girl on rollerblades throwing something away from her. So slightly different over the last 3 years. Question 5, the last question in the mechanics section, deals with work, energy, and power. It averages 14 marks. Not particularly well answered last year with an average of 48%, but there was a problem with question 5.4. But you can see in every case, you've got objects on an inclined plane and looking at changes in mechanical energy, potential, and kinetic energy. Question 6, the only question from the wave section, deals with the Doppler effect. A shorter question, averaging 12 marks, was quite well answered last year with an average of 58% as the students' marks. Last year we had a step graph showing the frequency before and then dropping and the frequency after the object has passed the listener. 2019, there was a question which caused a lot of difficulty. You have these sound graphs, and students really didn't know how to handle that. 2018 was a straightforward word question. Once again, we will deal with all of these questions very carefully. Question 7, the first of the electricity questions, deals with electrostatics. And this is usually divided into two parts. It's a longer question for about 18 marks. And normally there's something on charge conservation or Coulomb electric field and a secondary calculation after that. So you can see in each case, there's kind of two distinct questions that come up. The average last year, 52%, but the second part of the question, which you needed Pythagoras for, caused quite a lot of problems. So we'll look at that quite carefully. Question 8, sometimes in the older papers, it can be question 9, deals with electric circuits. Again, a long question, can be up to 19 marks, also internal resistance. Not particularly well answered last year, 48%. Last year was just a standard circuit analysis, making calculations of various currents and voltages. But the two previous years we had graphs. November 2019, a step graph showing the voltage drop when switch S is switched on. And November 2018, we had an internal resistance graph from an experiment. But the examiner changed the axes, and this was the worst answered question in the paper that year. You can see how often the worst answered question has to do with graphs. And I'm determined that that shouldn't be the case going forward. Question 9, the last electricity question, deals with electrodynamics. Shorter question, averaging 12 marks. An average mark last year, 50%. Again, this is divided into two distinct parts. You can see, first of all, there's a picture of an alternator, a generator, or a motor, and you asked various questions about it, which really are very simple and should be easy marks. The second part is always some sort of alternating current calculation. But again, this is one of the easier questions, but sadly it's often neglected because it's at the end of the paper and students run out of time. Finally, question 10, the photoelectric effect, a shorter question, averaging 13 marks. Last year, this was the worst answered question with an average of 43%. Quite often graphs come up here. You can see last year's question was a comparison of graphs for 3 different metals. November 2019, a standard graph from an experiment, but again, the examiner flipped the axes around and confused everybody. And this graph question was the worst answered question in November 2019. 2018 was a standard photoelectric effect calculation. Now, I must stress how important it is to focus on strategies and understanding. If you read the question paper and go straight to the answer in the memo, you will learn nothing because that exact question will never come up again. It's essential, and I will be encouraging you to do this throughout the videos, to look at the question, try it yourself first before I explain the answer. It's as important to know why you are going in the wrong direction as it is to find the correct answer. So in concluding this first introductory video, I want to remind you again just how important it is to focus on skills, not content, because facts fade, experiments expire, but skills stick. Let's have a look at what skills are required of you from the CAPS curriculum. So if you look at the bottom of your page 5, this is taken straight from the CAPS curriculum document for the teachers, but it has a list of 10 skills for physical science. And I want to tell you, these are not just for matric, these are important for life, and especially if, as I hope you will do, you go on to study science at university and to find a wonderful, fulfilling career in science. So let's go through these. First of all, you need to understand models in science. And you need to understand that things like our atomic model are just our attempt to understand what an atom looks like, because we can't really see it. So also the bonding models, the periodic table, this skill becomes more important in paper 2. Secondly, scientific notation. You will see that we're going to deal with some very large numbers and some very small numbers. And it's just not efficient to write them out with all their zeros. So we take something like 0.0065 meters, and rather write it in scientific notation. Please make sure you know how to do this and that you know how to put these numbers into your calculator correctly. Thirdly, conversion of units. It's important to be able to convert between units from simple ones like millimeters to meters to more complicated ones like square meters to square centimeters. Please also make sure that you know your metric prefixes like milli, kilo, mega, micro, nano, and so on, because these will not be given to you on your data sheets. Fourthly, changing the subject of a formula. You'll see many of these skills for science are actually mathematical skills. And very often, although your equation is given in one form, like V equals IR for Ohm's law, you want to solve for something like current, so you need to make it the subject of the formula. And you need to do that manipulation correctly to get a correct answer. Make sure that you practice that, please. Also, basic trigonometry skills, particularly when we look at vectors, when we look at triangles of forces, and this will come up especially in question number 2, and possibly question 7 as well, electrostatics. Fractions and ratios, again, more in chemistry, but also in physics. So an example, if a water molecule is 1/3 oxygen and 2/3 hydrogen, what is the ratio? Changing fractions to ratios and vice versa. Then especially in physics, but also in chemistry, what do we mean when we talk about rate? And a rate graph is always graphing something against time. An example is that power is the rate of doing work, and 1 watt is 1 joule per second. So please make sure you understand this idea of rate. Velocity is the rate of change of position. Acceleration is the rate of change of velocity. Number 8, direct and inverse proportions. And a good example of this is Newton's second law, which states that acceleration is directly proportional to force and inversely proportional to mass. So if you're trying to push a car, if you wanted to go faster, you must provide more force by having more people pushing. Also, if you wanted to go faster, you must make it as light as possible by taking the people out of the car. So that's a very important understanding. Another example is Boyle's law between pressure and volume of an inverse proportion. Number 9, constants in equations. You will be given these constants on your data sheets. You don't need to learn them, but you do need to know when to use them and how to use them, like big G for gravitation, K for Coulomb's law, and so on. Now, finally, practical investigation skills. Now, I'm well aware that probably most of you watching these videos do not go to schools that have science labs and science equipment. That is not the fault of your teachers, but I will endeavor to do as many experiments as possible with you in these videos so that you can learn these practical investigation skills. These are not just important for matric. They're used every time a doctor tries to diagnose what is wrong with a patient or a mechanic tries to find out why a car won't start. They are very important for life. So observation, precautions, writing hypothesis, and conclusions. Now, 3 important skills. The first one, skill A, data collection and handling in tables. Experiments produce a lot of data, a lot of numbers. You need to be able to collect that, export it into the appropriate form, which might be an equation, a table, a graph, a diagram, or all of these, and make sense of that data. Secondly, we've stressed already how important graphs are, general types of graphs, analysis, and how to analyze the information that's in a table, a graph, or a diagram. Practical things like finding the mean in statistics or determining the slope of a line. And finally, identifying variables, understanding which is your independent variable, which is your dependent variable, and which is your control variable. These skills are very important, not just for this series or for matric, but for life. To finish off with, again, a reminder that the examiner himself said that a severe lack of skills was evident when marking matric papers. These skills are mathematical, especially conceptual understanding and the integration of topics. Also problems with free body diagrams, graphs, and equations. So to finish off, I want to leave a challenge with you. Maybe you've been told that to pass matric, all you effectively need is 30%. And I want you to aim a little bit higher than that. Maybe you might pass matric, but I want to ask you, is a 30% understanding of science really good enough for the world that we live in? Imagine a scenario, you're in the dentist chair, you're a little bit scared of the dentist, you're covering your mouth because you don't want him to start drilling, you're hoping he's a good dentist, and the dentist tells you, don't worry, I passed dentistry with 32%. Would you be happy with that? Would that give you confidence in your dentist? Imagine again you're about to fly, maybe from Durban to Cape Town, and you get a chance to visit the cockpit and talk to the pilots, and they reassure you by saying, don't worry, I got my pilot's license with 34%. The other one adds, we're very good at flying, but we've never successfully landed yet. I think you'd be feeling a little bit nervous. Imagine that you take your car to the mechanic because the brakes aren't working and you're unable to stop and your car's become really dangerous. And he tells you, I hope your brakes will be fine. After all, I passed my mechanics exam with 33%. Would you be happy with that? And a final example, imagine you're waking up from an operation. They've been doing surgery on you and you're really nervous. And the surgeon reassures you and says, I hope I put everything back in the right place. You know, it should be okay mostly because I passed my surgery exam with 36%, but I'm not really too sure about the organs. Now, you understand I'm giving some ridiculous examples, but I want to challenge you. Look beyond your matric. Don't just think about becoming a matriculant. Think about becoming a surgeon, a mechanic, an airline pilot, a dentist, or a scientist. And South Africa today needs people with much more than 30% in the sciences. In fact, ideally, we need people who know almost everything because otherwise people could be killed. So I encourage you to raise your vision and to do as well as you possibly can. Not everybody can get 80%, but make sure that the mark you get reflects the best that you can possibly do. And I'm going to help you do that. So be encouraged when you think about your matric exam. Don't be scared, be prepared. Prepare yourself so that you will be ready to write the exam. Remember, the examiner is not out to trick you, he's out to test you. I encourage you to make full use of the booklet that you have, to watch every one of the videos again and again, to do the exercises before you go straight to the answers. And I can tell you, then the sky will be the limit for you. Thank you for listening. Please don't go away, but take some time to listen to a short interview with a young man for whom the sky really is the limit, and a young man whose generosity and interest in this program has enabled us to make these resources free for you. Okay, so I'm delighted to have the opportunity to interview Vusi Ngomezulu from Alan Gray. Vusi, how are you today?
I'm doing well, thanks. Happy to be here.
And you're joining us from Cape Town, I believe.
Yes, that's where I'm based. I'm based here in Cape Town. Yeah.
But Vusi, I believe that you grew up very close to Richards Bay, where Unizulu Science Centre is. Tell us where you grew up and what you went on to study.
And I attended Mpangeni High. That's why I matriculated. You know, so I've had a bit of a taste of like the township school and also a multiracial school at Mpangeni High, where I went there for grade 10 up until matric.
And after school, where did you study and what?
After school, that's when I came to Cape Town. I went to study at the University of Cape Town, and I pursued computer science as a degree, and ended up working as a software engineer at Alan Gray. Yeah.
Okay, and you also did quite a bit of physics, I believe.
Yeah, actually, in high school, physics was my subject of choice. I enjoyed physics and maths. And in actual fact, I got an A at my physics exam in matric. So it is possible, Welenis.
Okay. And you know David Wolf, of course, he was telling me you even had a chance for some studies in America.
Oh, yes, yes. Man, it seems like it's been a while, but yeah, in varsity, through my hard work and dedication, my academics enabled me to end up getting a scholarship, which took me abroad and stuff to go study at the University of Missouri. Over there, I spent a good 1 year studying computer science and other subjects over there and stuff. So everything was fully paid for, from the flights, going there, and even like my academics expenses and the cost of living and stuff. It was really
Fantastic.
amazing opportunity, which changed my life. Yeah.
So hard work can take you across the world. Now, Vusi, you're working as a software engineer in the financial world, and you're aware that this series of videos is about essential skills for the physics paper. Was there anything about your physics studies which helps you with what you're doing now?
Indeed, actually, you made that apparent to me by when I watched your first videos where you were like teaching about graphs and stuff, and how to understand them and interpret them. Strangely enough, like in high school and stuff, I didn't have that perspective that physics. I'm carrying on the skill that I learned in physics, but you made it apparent to me because of your style of teaching, and the way you've been teaching like this physics and stuff, by making it be so understandable that it is something that is even present in our day-to-day of life and stuff, and make it relatable. When I was still in high school, I think I got an A through my work ethic by practicing, doing a lot of like past question papers, but I didn't have this mindset of like I could see physics in reality and stuff. But after looking at your videos and now reflecting, I'm realizing, wow, actually, if I had this kind of way of thinking from the get-go, it would have been apparent to me that physics has been very essential in my career. And even right now at work, we do have to understand graphs with the systems that we develop. We have to kind of like monitor them, have metrics, have graphs to tell if they're working accordingly, if there's any errors that you have to troubleshoot. Yeah, so yeah, indeed.
That's fantastic. In fact, it's a fact that around the world, physics graduates are in great demand, particularly in the financial sector, and particularly for their problem-solving abilities, which are considered greater than people from any other discipline. Now, the South African Institute of Physics is, in fact, very grateful to the Alan Gray Foundation for some support. Can you tell us how that came about? Because I believe you were instrumental to that.
Well, there's an initiative at Alan Gray, which started I think a couple of years back. It's called the Alan Jill Gray Foundation Philanthropy Initiative with the employees of Alan Gray. So basically, the Alan Gray employees have the opportunity to nominate a public benefit organization of their choice. And for me, it was this initiative, like the South African Institute of Physics initiative, which involved training teachers to be better science teachers and stuff. I fell in love with this initiative and I nominated it. And the fate of the initiative was in the employees' hands, and the employees of Alan Gray voted for it to be considered for funding. And now it's a reality now, and I'm really it's my greatest achievement and stuff so thus far. And I am also proud of the South African Institute of Physics for being able to pull it off.
We really see you as a product of physics, and now through the support. And I really want to thank the Alan and Jill Gray Philanthropy Initiative, because it really is making a difference to young lives, and we hope to produce many more Vusis in future. So, Vusi, thank you so much. So you'd encourage the matrics who've just started watching these videos of mine, they should keep it up.
Please, guys, keep it up. Keep it up. This will give you a head start even for higher education. I'll give you my word. I also watch the videos myself. And I'm still when I have time to spare, I actually go and watch them and stuff. So they'll give you a head start for higher education. And matric is like a year which will really change your life and stuff, because through matric, you get accepted to varsity. I personally, my matric results helped me to get to varsity and also get myself a bursary at varsity and get to study at varsity for free. And as you said, Derek, I even ended up getting scholarship to go study abroad. So education is indeed the key to success.
Absolutely. In the words of Nelson Mandela, there's no greater way to change the world than through education. Vusi, thanks so much. Thank you for voting for the SAIP initiative. Thank you to Alan Gray for the support.